Hello students, welcome to the new course Tool and Die Design. In this playlist, we particularly grasp the knowledge how tool and die design help us to impart the product in a manufacturing setting and how it would help for imparting the final shape of the product in a manufacturing setting. Before formally starting this playlist, we need to grab some basic understanding of some subjects. Particularly, they are drawing, engineering drawing, materials engineering, manufacturing processes, and obviously computer aided design. So, moving to discuss uh, the content of the tool and die design course, we formally start by reviewing some basics. So we know that in a manufacturing system, we have some sort of starting material which is translated into the processed part by series of manufacturing processes which helps place in between two. Additionally, we have some sort of scrap and waste which is produced in addition to the final or the processed part. Furthermore, there are some material handling equipment which helps to transform the semi-finished or finished product from one station to another station along with some other machinery, tooling, power and labor requirements. So tooling is particularly our prime objective of this course, and we discuss this with respect to two aspects. The first one is the production and the other one is the inspection. So what actually the word seems to us like the tool, machine tool and tooling in a manufacturing context looks like a similar. So we particularly grasping our knowledge or to see how a tool or a machine tool or a tooling help us to impart the final shape of the product or the semi-finished shape of the product. Further, there are some inspection tools which help to check the conformance, quality requirements of the semi-finished or finished product. So particularly this course is evolved between these two tooling components, production toolings and the inspection tooling. From this slide, we came to know the manufacturing processes are divided in two forms, continuous manufacturing processes and discrete manufacturing processes. But for this course, we mainly focus on deformation processes, particulate processes, material removal processes, and some of the welding and soldering brazing processes. There are many other processes as well, but that was not in the scope of this playlist. Under the solidification processes, we primarily build our discussion on permanent mold casting processes instead of the expandable mold casting processes. And we also look the injection molding or related processes. In this slide of the solidification processes, which is the process showing the die casting, and we have in figure illustration 1, we have the die closed with the plunger withdrawn, the molten metal flows into the chamber. So here you can see we have a chamber and this plot contain the molten metal, and this plunger when applies the force this downward direction fill this molten metal into this cavity which help to create the near net or net shape of the product. So particularly this course is focused primarily focused on this production tooling which help to impart the final or the near net shape. So these 1, 2, 3 illustration represent the manufacturing processes steps like this one is the initial step, this one is the second step in which plunger apply force in the downward direction, and in this third step the plunger force is removed and the final or the near net shape product is drawn outside. In this processes, the mainly as the art concern is the tool which help to create part. This part consists of a different kinds of tooling types. The first one is the single cavity die. The others are multi-cavity, combination die set, or a unit die set. The difference between these dies to this single cavity is represent the multi-cavity consists of the similar type of shapes which is produced from multi-cavity die. In combination of die set, we have two different type of products which would be manufactured by using this tooling. And lastly, a unit die which consists of a one product of relatively large in shape and the other multiple of the other type of product which is relatively of small shape. So from this slide we came to know that the tooling in this case is the single cavity die or other type of dies are the important component of this solidification process, die casting process to create the part. So ultimately this course actually evolved around the production tooling as I said before or the inspection tooling. So I would request you to pay attention on the tools which is particularly used in different kind of processes such as this polymerization based process or injection molding process are again prime focus area is this mold which is help to produce the shape. So in this simple illustration we have a two units, the injection unit and the clamping unit. In injection unit what we see here, the hopper actually feeds the granules and this screw reciprocatory screw move forward the hoppers to the mold for producing the shape, and there are some heating chambers installed on this screw which is actually melt this feed hopper. Plastic granules are melted by using these heating chambers, and this is the clamping cylinder which actually clamp this mold. This one is the stationary plate and this one is the movable platen which help to remove the part from the mold. So again mold is the most important component in this manufacturing process. So again as the previously described die casting process, we have different kind of injection mold such as we have a two plate mold or more than two plates mold such as a three plate mold. Let's discuss the two plate mold first. In this two plate mold we able to get a two shapes at a time as an output, while in three plate mold we again collect the two shape as an output such as shown here. The difference between the two plate and three plate thermoplastic injection molding process mold is between this intermediate mold plate which help us to separate the sprue and runner from the final shape of the part. In this figure you can clearly see the output is not a net shape, it is near net shape output, which means we need to remove this sprue and runner from our final product. So design is primarily important with respect to our course, how this tooling help us to create the final product, and definitely with this design we have to spend some time. So with respect to time and productivity requirements, you have to uh, look these factors. So when we move to the other type of mold which is three plate mold, here you can see we don't need any additional step to produce the final shape. Then we have a particulate processing. In this process, again, the composition of metal powder to form a machine is represented in figure A, and the figure B illustrate the typical tool and die set for trumpeting a spur gear. So we are actually producing this final product by using this die set. So again, designing or construction of this die is important in this particulate processing. In particulate processes, we normally have the metal powder, which is pre-processed based upon some sort of processes as mentioned. Then we have the additive lubricant to blend these metals. Then we may use some methods based upon cold compaction, hot compaction, and then we have the secondary or the finishing operation. When we consider the cold compaction based processes, we have to uh, flow to the sintering processes. Consider these sintering processes. So this is the illustration of the particulate processes. I'm not going in detail of these processes because you have already covered these things in your manufacturing processes subject. But our main focus is to design of this die, which is actually help to create this part. And these are the steps, like this is the lower punch which apply the force in this upward direction, and the upper punch apply force in downward direction, and based upon this compaction we able to achieve this final product. This is the illustration. On the left hand side is typically the press. This is again the machine tool. This machine is actually help to install this die unit on it for producing the shape. I repeat again, please pay attention on the machine tools or the tooling. Tooling in this case is shown on the right hand side, which is this die set, and the die is installed on this die set, and this die set is actually installed on this machine, which is typically a press. So particularly from press we able to install the die in this machine to produce this final shape of the part. Then after the solidification type of processes, we have the deformation processes. In this deformation processes, we have start with the forging processes, in which the starting material of the metal is red hot format, and we have the different kinds of mold again, which is used in the forging processes, such as open die forging, or the impression die forging, or the flashless forging. So there are different of pros and cons of each type of dies. For example, in this open die forging, we have actually compressed the workpiece between these two upper and lower die set to reduce the height of the product and increase its width, right? In this case, we have a closed near net shape process, and this impression die forging would create some flash which needs to be removed by some sort of machining processes. And this one is the closed die forging, which produce the exact shape of the workpiece. But again, the material requirements plunging into this type of die is really important, because adding less sort of material to this type of die set would produce a faulty product, or excessive material would again produce the faulty product, because the excess material would not properly be able to close this process, and the size of the shape would be large in this case if the excess amount of material is added into this type of die set. So again, the designing of the forging die is important in this process. Then we have the extrusion processes, and we have direct and indirect extrusion process. I'm not gonna go on into the detail of these extrusion processes, but again here the design requirement of the extrusion die is important, in which the ram is uh, applying or directing the force in this side, and the other side produce the final shape like this. And we can produce the hollow or completely filled product by using the um, construction by constructing the designing of that kind of dies. For example, here you can see some type of product which is produced from the extrusion processes such as the hollow and the semi-hollow cross sections product. In this inter extrusion product, the force is applied in this side and the product is produced as a solid or from this A type of die, and the hollow cross section is produced from this B type of die design. So actually we apply the force in this side, and in between there is opening which produce a solid cross section rod. And here you can see we apply again the force in between of the die, and the opening of the cross section around these ram produce the hollow cross section of the product. So finally we have the shearing or blanting and piercing operations, particularly occur in sheet metal based processes. Again, the designing of the sheet metal dies are important. This systematic illustration shows the before and after of the blanting processes. So you can see we have a punch and the die, and here is the sheet metal strip which is moved in this direction, and the punch is moved this direction to produce a blend. This is the before and this one is the after of the illustration, opening and the closing. So here you can see two different uh, operations are performed in this progressive type of dies where blending and piercing process will be occur. So you can see first the slug is produced, which is in the first operation. Then we have the part, which is the required shape, and this strip is the strap. So this one is the finishing washer. So in this process, you may see the die, or which is actually important to produce the final shape. Either we can design two different kind of dies. First one is for the piercing part and the other one for the blanking part. So combining those two operations in a single die is the definitely reduce the design cost based upon the production of dies cost. Definitely first you design the die which is helpful to produce the part, and if you separate these two processes from separate two kind of dies, then definitely you have to put extra energies for producing those two different type of dies. So again, designing of dies is important. So here you can see some blending operations which is shown from A to E, and this one is the press, which is again machine tool and help us to install the die on it and to produce the final shape of the part. So here you can clearly see the blend and the drawn cup from this illustration A and B. So here you can see that we have a blend and the punch is moved in downward side, which help to create this cup or the drying process. Okay, so next we have the material removal processes, and the current illustration representing the various kinds of conventional machining, abrasive based processes, and non-traditional machining processes. So particularly in material removal processes are the area of concerns are the tools which is used for removing the materials from the blocks or blooms or rectangular plate or irregular plates, so on and so forth. So actually we have different kinds of uh, illustration. In this illustration, the first one which is in which the tool actually rotates, and it rotates either in horizontal or vertical base machine, and these are the drill press, milling machines. Again we have the both kinds of milling machine, horizontal and vertical milling machine, and the horizontal boring machine. So the designing of this tool, which is actually help to create the shape of the part, is prime importance in these subjects. Okay, so the other side of illustration represent the in which instead of the tool rotates, workpiece are rotates. And again, they have followed the same analogy, vertical machine and horizontal base machines. And these are the some other subcategories which falls under these two different kinds of machines. So again, in this illustration, the tool is the prime factor which is used to shape the final part of the product. And again, this one again in which tool is rotate, but we have different kinds of machine like broaching machine, shaper machine, or the planer machine. So in sum up, in material removal processes, we have a different kinds of tools, single point cutting tool or multi-point cutting tool, and the drill bits, which is actually the most important thing with respect to tool and die design course, are the important in their designing, in their construction for producing the final shape of the part. So uh, in a nutshell, this tool and die design process evolve with respect to the two prime component as I explained in the start of the presentation, that is the production tooling and the inspection tooling. So up till what we have discussed, it's all related to the production tooling perspective. So this one is the illustration of the drill bit and its rotation. This one is the lathe operation, and these are the milling operations. So these are the different kinds of tool as I explained before, a single point and the multi-point cutting tool. Finally, we have some assembly operations, which is actually to join the two plates or the two parts, and these assembly operations could be the welding based processes or soldering or brazing based processes. So in these kind of processes, the tool is basically the machine or the component which is held the more filler metal to join these two plates, such as here you can see the configuration of electrical circle of an arc welding processes. Now we have the exposure test up till what we have learned so far. So to produce this final shape of the part, which is again we need definitely engineering drawing which explain the detail. And this one is the starting material, a blank, and we have the machine tool and the drilling tool which is used to produce this final shape of the part. So we need a drill bit, definitely an example of the cutting tool to drill the holes. So the question one is the core. So the core question here: how to drill the 12 holes repeatedly, quickly, and accurately? For that, we need the drilling jig, an example of the production tooling, and how we can inspect either these 12 holes are accurately and drill at their desired position. We need the inspection gauge. So the tool which is directly used in the manufacturing processes, what we have covered so far in this lecture, are the machine tool or the tools which is help to which is directly involved for producing the part. But construction or designing a jig which is help to create these hole at the accurate position is helping us to create this final shape of the part, and drill is directly involved, and this is help us to impart the final shape of the part. And after their production we need to examine, and for examine we have separate different kinds of gauges, so such as go no go gauges, and we have different kind of geometric tolerance based components which is help to check either the plate surface if horizontal properly or uneven, and so on and so forth, which will be covered later in this course. So such gauges are the inspection gauges. The second test is related to the sheet metal working, and this one is the final part which is need to produce, and it's again start from the strips, metal strips, and this one is the first blend, and this is the press which is a machine tool, and a die install on it, and to produce by series of operation we able to produce this final shape of the part. So how many operations are required to make the final part starting with the sheet metal strip? And depending on the number of operations required, production tooling, a punch and die, is designed for each operation. Definitely, if we have a 5 number of operations which is required to produce this final part, it means we have to design 5 different operations die set, dies, punch and dies, which is installed on die set, and those die set are installed on the press, which is help to achieve this final product. You may guess, again, I'm sure you guess is fine. We need 5 different operations to produce this shape. So again, for the 5 pairs of the punch and dies are being used, and the tooling are the custom design. And how we can inspect the final part? Definitely again we use the inspection gauge to inspect the final part. When it comes to the die casting example, again we have the part to be made and the starting material, which is the molten alloy, and we have the die casting press, a general purpose machine. And through the help of this die casting mold, we have quickly, accurately produce high volume of the final product. So we need a die casting which have two half. First is the cover die and the moving ejector die. And to verify the critical features of the final casting, we need to inspect fixture gauge and row and no row pins and the height stops. Finally, we have the injection molding example, which is the final shape of the part, a bucket, and starting material are the plastic pellets. And definitely we need injection molding machine, a general purpose machine, a machine tool, and we need an injection mold, which is help to produce this final shape of the part. And definitely the mold is consist of 2 parts, core and the cavity. So it's all about this lecture. Here we grab some sound understanding about the manufacturing processes, particularly with respect to the tools which is used to produce the final part, which is directly involved in producing the final part. I can rephrase my statement like which is directly involved for producing the final part, and how we can design those tools, which will be covered later in this course. Hope you like this video. Consider subscribing. Signing off, Asim Amjad.